This DB2's Brother Panther. I've got a database here I've been monitoring. I'm going to do a response time analysis for this database, and what I see here is for the last 8 hours, not much going on. I actually want to look at the entire week, so I'm going to look at the performance of this database for the week, and I've got a 1/4 second response time. 85% of that time is inside the database, and the database is a little bit more I/O bound than CPU bound. I'm going to click on that I/O pie slice, and Brother Panther just did the analysis to find the statements that are causing that database to be I/O bound. So right there, I've got about 2/3 of all the I/O in the database tied up in these 4 statements. I can pass those as a workload to the design advisor and apply DB2's advanced index benefit analysis methodology. So here's an I/O bound database, 2/3 of all the I/O in 4 statements. We're waiting for the answer here. Do-dee-doo-dee-doo-dee-doo. Oh, outstanding. And we can see we're going to get from 374,000 time rounds down to 116 for a 99% improvement. Here's the indexes that we have the opportunity to create, and we can see the benefit of each of these indexes. If we add this first index, we'll get 49% of that savings. If we add this second index, we get 46% of that savings. And if we add this third index, well, it's not a very big contributor to all that savings. So I take these first 2, that's the bulk of my savings, click on create. There they are in my editor. I'm ready to go. And just like that, in about a minute, I just took 2/3 of the I/O out of an I/O bound database. Isn't that easy? Yes, it is.
Okay. Hello, I am Eswar. My topic for today is if given an RID, how would you translate that into a value in a table? So, what is an RID? The table in DB2 consists of rows and columns. A row is a record, and each record is identified by a unique RID or a record identifier. The RIDs are stored in index page sets, and this index page correspondingly relates to a data page in the table. So there are two ways in which an RID is stored. There is a 5-byte RID and a 4-byte RID. So if you have a universal table space or a table space that is defined with large keyword or with a DS size parameter, DS size is a data set size. The RID is a 5-byte field containing 4 bytes page number and 1 byte ID map entry number. Similarly, for any other type of table spaces like a segmented or a simple or a classic partitioned, you would have a 4-byte RID, which 3 bytes of page number consists of 3-byte page number and 1 byte ID map number. What is a page number? A page number is a part of a page set, which is a physical grouping of pages where the record is stored. So for in an RID, the 3-byte or the 4-byte consists of the page number. So for a partition table spaces, partition page sets, we have something called a high order bits, or in binary the first digits, first 4 or first 6 or first 12 digits. Where using the page number, we can locate the partition number. So the partition in an RID, partition number based on the page number, always starts with 0. It is not related to a table where you have partition starting from 1 to 4096, but in RID, the partition number always starts with 0. So if your page set has 3 partitions, that would be 0, 1, and 2. The numbers would be 0, 1, and 2. Please stop me if I am not audible or if I am too fast. So to follow the partition number, we divide the table space into 2 types. One is non-EA enabled. EA means extended addressability.
Wonderful. And with 7 seconds to spare, you practiced your timing. It was delivered wonderfully, and I don't work that much on DB2 mainframe, but I think you gave people a secret decoder ring for figuring stuff out. I was impressed. I'm going to ask my judges to give their opinions, and then I'm going to ask our studio audience to render their opinion on a little polling question, and then we'll get the scoring from our judges. Martin, what did you think?